Hello, good morning. Thanks so much for joining me in my shop here. It's July 14th, and today is going to be tube testing day for this radio. And how many tubes is that? It's quite a few. There's a lot of tubes in this radio. 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9 tubes. That's a lot. In a radio like this, these two, I'm pretty sure, are identical tubes that are actually feeding the power to the speaker. This guy is involved in the rectification of the power that's coming from the wall. They change it into direct current. This guy, almost certainly this guy, is in charge of strengthening the signal that's coming off the antenna, make it a little stronger. This guy has an important job of converting the frequency from the antenna to a fixed frequency for the rest of the radio. This guy is amplifying that fixed frequency, and this guy is separating out, or is involved with separating out, the audio that's going to go to the speaker from the radio stuff that came on the antenna. And way in the back here is another tube. I don't know what that's doing. I don't know what that's there for. Just now. Oh, you know what? Push pull. So, inverter. So this tube is probably an inverter tube. Inverter? Yeah, again, that's the right term. Inverter. So maybe we'll just go through them from the antenna end and head towards the output. But we'll start with the power supply tube. This is a, there it is, 5Y4. 5Y4. Now we're going to turn our attention to the tube tester. I'm going to explain a little bit about this tube tester. There's two types of tube testers in this world. There's probably more than two, but there's two basic types. One is a very simple one, and the other one is a little more complicated. This is a little more complicated. This one's capable of making an important measurement that you can judge the ability of the tube to amplify or oscillate, I guess would be the case too. So it has a number of tubes listed here, hundreds of tubes listed on this chart. Just read the numbers, set the controls, push the right button, read the meter. Now you can see on the meter good and bad. Good and replace, actually. So if I flip this meter scale knob to this setting where it says replace and good, then we could just run the tube test, and if the meter comes in the good, it's good, and if it's in the replace, time to go. So that's a very simple sort of interpretation of the results. Or we could do something a little more quantitative. If we put this on one of the other scales, 3,000, 6,000, or 15,000, and the three scales appear here, then we can actually get a reading of the mutual conductance. See the word right there? Mutual conductance, transconductance, GM. It's got different names for this for the way a tube behaves. I guess that's the best way I can put it. So our first tube is a 5U4. No, 5Y4. Get it right, Jim? Oh, that's your classic mistake right there. 5Y4. So we'll look up 5Y4 on the chart here. Look here. 5Y4. There it is. It appears twice. There's two different settings. If you look in the tube, it's a little hard. The tube is pretty dirty. You can see there's actually two structures inside. There's actually two tubes in one. They could have done this under two glass bulbs. You could have had two tubes. But they packed it in one here. That's why there's two sets of settings. Okay, so first thing we set is the filament voltage. The rectifier tubes run at 5 volts for some reason. I don't know exactly. Most tubes run at 6 or 12. Now we start setting these knobs. JX, these are actually the connections to the heater. in the tube, so that's set. And next are 0, 5, 0, 0, 0. So lots of zeros when you do a rectifier tube. Not a lot of elements in the tube. 0. Bias control set to 0. There's no bias for rectifier tube. English. So this is a setting, English, which controls the replace and good setting. That's all it does. It just makes this work. So it recalibrates the meter, if you like, so this will be true. I'll set it, but we won't be using it because I always read the actual number. I'll set it though, just to be sure. Next, it's telling us to push P3. So push button 3. You can see the word rectifier written there. Maybe you can't. It says rectifier, and that's what we're doing. We're testing a rectifier. Okay, time to put the tube in. Now, we know the tube works because the radio works. So all the tubes I'm going to test are going to work. It's a question of how well they work. So before I do that, always do a double check. That's usually what I put on the video, is me doing the double check. 5 volts on the filament, J, X for the heater, 0, 5, 0, 0, 0, 0, 5, 0, 0, 0, 0, and unimportant 16. Okay, we'll plug the tube in. You can see there's all kinds of sockets here. This is the one. In it goes. And of course, another leader factor is turning this on. You need to have it turned on. Now these tube testers do not try to simulate a radio or some other electronic circuit like that. A circuit, a tube like that might find itself in. These tube testers have their own circuits designed to reveal what has to be revealed, but they do not actually operate the tube in a normal way. But basically, the engineers figured out the cheapest way to do this, and it's very effective. So, also, when it reads this factor called Mutual Conductance, Transconductance, or GM, it's reading it in conjunction with the way it's testing the tube. So there is no fixed GM for a tube. It all depends on plate voltage and other factors, so the GM can range. So each tube tester is going to give you a value as a target for good and bad. That value may be different from tester to tester. So so that's the truth. That's the truth. So what do we expect here? So in this case, because it's a rectifier, there is no mutual or transconductance to measure. So instead, this is going to measure the ability of the tube to conduct current, which of course is the big issue with a rectifier tube. Can it conduct its current? Push P3. Now, I'm going to take back something I said. Because there's no mutual conductance to measure in a tube of this sort, this has to be on English. We have to use the good and the bad part of this. Here we go. P3. What's it say? Okay, so the shaking of the needle around is probably from dirt on the button here. That's all. Look at it. It's right. It's on the question mark. So back in the 1950s, hey, that tube would get replaced. But today, not so fast. It's still operating. Now let's test the other half of this tube. We've only done one half. The other half. All we got to do is change. Well, the English would change, but again, we are using it. We are relying on it. Ooh, yes, 16. Press P3. Change this to 3. In some tube testers, you don't dare change switches like this with a tube in place. This one's okay though. This one's fine. This is a very popular. There's a lot of these in Canada. A lot of these testers, quite popular. Okay, we push the button. What do we get? Good. So a little out of balance. I think it's so low now. Bottom line is, this tube is operating, and for now, there's no need to be concerned about it. Yeah, it might be a little worn out. The different tubes experience different amounts of stress in a radio like this. This one takes about the most. One of the signs of that is how big the tube is. Why is it so big? Because it's passing a lot of current. The parts inside have to be large to pass that current. And it's designed to run pretty hot. This tube gets hot. You wouldn't want to grab this one while it's operating, that's for sure. So, there's a couple other tubes that get hot in here, quite hot. These are these output tubes. They're also working very hard to drive the speaker. You see they're bigger. Now these have a steel can on top of them. All these tubes have a steel can over them. So you can't see the glass. But there's glass inside them. But they have to be glass because it's the only way to make them airtight. I'm really... Am I sure of that? I never smashed one of these open. Pretty sure that it's glass inside. Doesn't make any difference anyway. Now, should we just continue along in reverse? Why don't we do that? The thing that's triggered me to do the tube testing is the weak output in the radio. And there's a really good chance the weak output is from weak output tubes. So why don't we give these, we'll do it in reverse. We'll go from the speaker and we'll kind of work our way back to the antenna. Why don't we do that? This is a 6F6. This guy's probably the very same, 6F6. These two together drive the speaker. And I won't go into how it does it, why there's two of them. The two of them gives you a number of advantages. You get two tubes working on your speaker, you get that much more power. But there's some other interesting advantages in how these tubes are utilized in the radio, in the push-pull circuit. I won't go into it. Okay, so it's going to be 6.3, I already know that. 6F6. F6. There's 6F6. One test. 6.3, as I said. JR. 5347. 5347. The 2 on the end. 2973. Now you might say, well, how accurate is this guy? Look at this old tube tester. So I have got a number of tube testers. All of them, of course, are vintage, but in varying ages and that. And they all agree. They all agree. If you have a bad tube, any one of them will spot it. So I'm quite reassured with these machines. I tend to be doubting Thomas, is that the word for it? I tend to be like that. 6F6, we'll double check now. 6F6, 53472. 53472. Okay, stick it in, we'll get it warming up. Now you may have noticed the pilot light flicker there when I first put the tube in, because the filament in here that's eventually going to warm up is cold. Resistance is low and it draws a chunk of current at first. The current rushes in and it robs the light here of current for a brief moment. That's actually an element of a test. When you plug a tube in, it should make this light flicker a little bit. If it doesn't, maybe the heater's not working in the tube. Okay. Now in this case we are going to push this P for GM and we are going to get a reading. We're going to put this on the 3000 scale. This tube tester gives you two numbers to look for. It gives you a number of what it should be if it's okay, and a number at the lowest you should accept the tube at, or the reject point. 1260 is the reject point for a 6F6. The 3000 scale, 1260, well it's right here where my finger is, just under the E in the word replace. Will the meter get past there? Now something I neglected to do on the last tube test, and shame on me. Why that is, I don't know, talking too much. There's a test here that looks for short circuits within the tube. Now if any of these tubes have a short circuit, chances are that radio would not have worked at all. So I'm not expecting to find anything. what we do is we just go through these numbers here, 1 to 5, and watch for the short light to stay on. Flashing is fine, doesn't mean anything. Does it stay on? No, it does not stay on. No shorts. If there was a short, we wouldn't test the tube, because it might be the end of my tube tester. And now, here we go. Where was it supposed to go? Up around the E and replace. It's a beauty. That's a beauty. Now, you read a lot or you see a lot on eBay and whatnot about matched pairs of tubes. Yeah. Let's see if these ones match. So we'll note the number here is 1750. 1750. That tube got pretty warm. 1750. There's the other tube. Saw the pilot flash. Let's give it a moment. So it has a heater inside, a heating element, just like you might imagine, that heats up. And in most tubes, that heating element is then inside of a metal sleeve. So the heating element's in here. And the real job is to heat the sleeve up. And that takes time for the heater to heat up and then the sleeve to heat up. And that's what takes time when you turn these tubes on until they get hot. Here we go. Is there a short? So we're watching the flashing light. No. Do I find shorted tubes? Oh yes. We're ready now? How does it compare? The last one was 1750, right around my finger. Oh! Oh. It's climbing a bit though. So it's still warming up. Now, it's not replacing good, right? It's actual number. So the actual number's over here, 1260. So 1260, they're saying at 1260, time to get a new tube. So it'd be 1011, 1260, just where my finger is. Well, it's actually climbed a little higher. What happens if we do flip it to the, I don't know if this is set right. Did I set this right? 73. It is. Let's put it on English, just for fun. Good enough, but I think you'd be hard pressed to call those a matched pair. How important is that in this radio? That they be very closely matched? You know, that this isn't exactly an audiophile stereo we're looking at here. Probably the kind of distortion that might happen. It's so subtle, you'd never know it. The other day I was listening to, I was watching something on television. I had my headphones on. It was music, actually. I had my headphones on. And while I'm listening, I became aware that the left channel was distorted. I could hear it. You know, it's very hard to describe distortion, but let's just say I could hear something that didn't seem quite right. So I took my headphones, I flipped them around to hear the distortion go to my other ear. And it didn't. The distortion was in my head. What? Wow, I'm going to have to look into that a little further at some point. So it's on fairly high volumes. I could begin to hear what sounded like clipping or something like that going on, but it's all in my head. Oh my gosh. Okay, next tube in the lineup would be, I guess, the inverter tube. We'll pull it out here. Well, that guy, wow, he really wanted to get out of there. Holy smokes. Oh, wait a minute. This is the SQ7. This is an SQ7. Well, they're using an SQ7 as an inverter tube, I think. We'll only know when I study up on the schematic eventually. We have 2 6 SQ7s to test. Okay. 2 6 SQ7s. 6 SQ7, so we're looking up here. SQRS. How's that alphabet work again? 6 SQ. SQ7. 3 tests for this tube. Although the first one may reveal all. 6.3. JX. JX. 1603 with a 2. 1, 6, 0, 3 with a 2 on the end. 11 for the bias. 34 for the English. So this is a this tube has 3 tests, as I mentioned. There's a triode amplifier in this tube and then 2 diodes. So we're doing the triode first. Triode has a mutual conductance. So we're going to see that it has to come up above 470 on the meter. It's not very far. That's just here. Just got to get past 470. Okay, so we'll do the short test. You're watching from there. You have to plug the tube in before you can test it, Jim. Ultimately, pushing this button and seeing the meter not move would have revealed that there's no tube in the tube tester. Let's give it a moment to warm up. Shorts in a tube can occur after it's been operating for a minute or two. As the elements in the tube heat up, they shift, expand a little bit and shift a little bit, and the short can come in and go out. You can have a heater. This is my heater. You have a heater that you turn it on, it starts heating up. But as soon as it heats up, just like my fingers separated, a separation takes place in the heater and the electricity stops, cools down, and then it makes contact again. Starts heating up until it separates again. So you can have this kind of thing going on in a tube. It takes time to find that. I'm not spending a lot of time on the tube tester here. But those kinds of problems will show up in the radio itself. So usually this light flashes quite distinctly. When it doesn't flash, it suggests the tube is weak. Let's see if it really is. Is everything set correctly here? So we're on the 3000 scale, looking for 470. Hit the button. Well, I'm not expecting a 0 here. So you get a 0 when the heater isn't heated. 6SQ7. I'm talking so much I could easily make a mistake here. JX. This is in a radio that appeared to work, but if you remember, the output was low. That's how I remember it anyway. This could be the cause right here. So no movement. So now a couple things can be happening here. One, I got the settings wrong. 2, the tube has not made contact in the socket. That's all that's happened. I have trouble with these sockets sometimes. So I got to figure these out. So first of all, we're going to watch the pilot light. As I put the tube in and out of the socket, we're going to see if the light flickers a bit. I didn't see a thing there. Let me put it back in. This is where we'll see it. I saw something, I think. There's a little tiny flicker there. So I think the situation is we have a bad tube here. That's what I think. Test. It's just not moving at all. Okay, so we'll perform the next test, and if it shows up as a dead, I think that tells us the heater is not heating in this tube. So JX 0503 with a 6. 0503 with a 6. This is one of the few tubes that could fail and the radio still operate well enough to fool somebody. We bias at 11, English to 0. P1 now, we're pushing this button, the diode test button. I didn't change any of these, did I? 0503 with a 6. did. And talking and doing and not thinking very hard. This is where mistakes happen. Do the short thing again, just in case. You see a tiny little flash there, almost nothing. P1. Well, is it even worth doing the next test? Just for the sake of doing it, all we do is snap this from 5 to 4 and push the button again. So this tube is a dudden. I'd say it's warming up ever so slightly, but it could just be, I've been handling it. Doesn't work. Okay, so I'm going to put that upside down here in the radio. We're going to go on to the next tube. It's the same tube. Same type of tube, 6SQ7. A little dusty. So this time when I plug it in, we'll watch for the pilot light. This one, is, can I say that? More integral to the operation of the radio? Well, probably. This is the one, the diodes are being utilized in this tube. In the other tube, the diodes were probably not being utilized for anything. Watch the light. There's a flicker. Not much different than the last one. Have I done something stupid here? 6.3 volts. So we're going to start with the diode tests and work our way up to the triode. Let's look for shorts. Now see that flash? Now that's what I expect, to flash like that. Testing the diode, just pushing P1 on English. Should be on English. P1. There we go. In the good. Change the 4 to a 5. P1. Not in the good. And I'm holding the button to see if the meter is syncing. Just another, and it is. It's slowly. Well, maybe not. It's definitely in the replace zone. Okay, now we'll do the important triode. 1603 with a 2. 1603 2. 1134. 4. Put it onto the 3000 scale. 470 right down here. Any shorts showing up? Shouldn't be. And we push the button. Oh! Oh! Ooh. So you have two 6SQ7s that are, wow, that's bad. No, wait a minute, 470. Yeah, it looks bad in terms of the whole scale, but it only needs to get to here to pass. It doesn't get there. And if it were really good, there's sort of like a new tube, it would come up to 750. It would be way up here, like that. That's two 6SQ7s, which I have replacements. No worries. Two of them, though. Well, that would certainly explain why the radio was weak right there. We have 3 more tubes to do here. So we've done all these. We have just these 3 left, plus the magic eye, which is an interesting tube. You know what? I might just take a break right now and go drink some coffee. I think I'm going to do that. Coffee. Coffee Achiever. Okay, nothing like a bit of coffee in the morning. Coffee Achievers. I've mentioned this before. Coffee Achievers. Type that into Google. Work your way to some TV ads from the 1970s, early 1970s. Join the Coffee Achievers. Okay. Check that out. Here we go. I've already set the controls. Let's double check them now. 6SK7. So JR. these roll charts have a way of rolling, you know, a tube or two, and then you look over and you're looking at the wrong numbers. 4765, 4765, 3, 22, 72. We're on the 3000 scale. This tube should, if it's a good one, 6SK7, good one would be 1900, replace it at 1200. So, you know, 1200 is around here, 1900 is way up here. This tube is a really important tube in the radio. This tube, or its position in the radio anyway, it's the intermediate frequency amplifier, and its main job is to boost the I'll say strength, boost the strength of the radio so it can pick up stations very, very clearly and the like. This tube's weak, the whole radio would be weak. Is this tube weak? Well, is it shorted? No, of course not. The way a short can develop in these tubes is the elements are located concentrically, right? They're like this. There's 3, 4, 5 elements, kind of like this, and you know they're made of metal, and stuff happens, and they can bend and twist a little bit. Before you know it, there's a contact inside the tube, which is the short, which we don't want. There are no shorts. Did I push the button already? Here we are. So the reading on here, and it's falling a little bit. 1600. 1600 on the meter. Checking again. So this is moved. 6SK7. 1200. So we're good. We're right in the middle between 1200 and 1900. So this guy's good. Let's check it again. 1600. Good one. Now I'm going to pull out another tube here. Actually, I'll show you what it is here. Just putting this one back in. 2 more tubes left. This guy is the same tube as this one, the 6SK7, the one we just tested here. Same tube, so we're going to do this one next. Saves me from resetting the tube tester. This guy has a similar job, except he's not working in the intermediate frequency zone. I'm indicating these 2 cans for a good reason. This guy's working right off the antenna. So he's taking the fresh antenna signal, giving it a boost, and sending it on its way over to this tube. This tube, as I mentioned before, is changing the frequency from what is on the antenna. For instance, maybe you're going to tune in 1010 CFRB in Toronto. At 1010, what's 1,010,000 cycles per second? After going through this tube, it'll be converted to probably 455 kilocycles to continue on through the radio. We'll talk more about that as I go. But 6SK7, okay. Just giving a little bit of radio theory for anyone who has very little, very little notions of what's going on in these radios. So here we go. My notions are just a little better than that. Do I have false notions? How do you know when you have a false notion? And no answer comes the reply. Somebody tells you. This brings me back to the importance of speaking with great fidelity when you're talking to somebody about something important. You need to use lots of words, lots of descriptions, and really get into the nitty-gritty. And the reason for that is as you're talking to this other person and explaining whatever it is you're explaining, they can pick up on where you're going wrong and help you understand that and tell you about it. But if you talk in big, high-level terms, 90,000 feet off the ground, nobody knows what the details are, and you don't either necessarily, and nobody can poke at what you're saying, and you can't get the help you need to figure out the truth, and you're heirs of your own way. So when important things are being talked about, use lots of words. And that's what I'm doing. I'm verbose. 6SK7 shorts. Get back to what I'm doing here. No shorts showing up. Dun, 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 dun. Another good one. Very good. Okay, so these are two pretty important tubes for the performance of the radio. That's really good. Both of these are really kind of the amplifier tubes. I should take that back. They are amplifying the radio signal. You have other tubes amplifying the audio signal, right? Radio stuff here, audio stuff down here. Last tube. This guy is the frequency changer, the converter, the mixer. All kinds of names for this tube. And it is a 6SA7. This tube is presented with two signals, and this is something I think few people would know. Unless you're into this, you would never know it. But there's a radio transmitter inside your radio. What? That's right, it's called a local oscillator. And when you're turning the tuning dial, you're changing the frequency of this other signal. You're not actually tuning, well, to some degree you are, but on a higher level, you aren't actually tuning the signal. You are tuning this local oscillator. That local oscillator signal is fed into this tube on one of these pins. Meanwhile, the signal from the antenna is coming in on another pin. Inside the tube, they get mixed together. And then oddly enough, what comes out are four signals. You put in two, you get out four. You put in two, you get those two, and additionally, you get the sum of the two signals. What? What do you mean sum? And the difference. What? That's right. You get four coming out of this thing. One of them is really important. Well, one of them, it's my ring finger, but I can't make it stand up on its own. Can I? Yeah. So two signals in, four signals out, and one of them is the important signal that we want to continue through the radio, and all the rest get dumped, including the original signal coming in on the antenna. The original signal coming in on the antenna makes it to this tube and no further. This is the end of the road, but it's coming in at a certain frequency and in a sense going out at another frequency. You can think of it that way. And why is this done? Because it makes the radio very, very good. Very good. Makes it has benefits for how a radio is designed and how well it works with how many tubes and all that other stuff, how easy it is to tune, how well it can select a station over others. That's a very important factor. And how sensitive it is. All these things are improved by the use of this technique, this conversion technique, and the subsequent circuits, which I won't go any further into it. Once again, I'm talking too much. 6SA7, two tests here. 7, 3, 4, 6. 7, 3, 4, 6. And although I didn't say it, I did double check JR. 5 on the end here. 5. Let's double check that because I was talking. 7, 3, 4, 6 with a 5. 7, 3, 4, 6 with a 5. 21. Bias. 34 English. Press B4. First one we're testing is an amplifier section of this tube. Here we go. I didn't mention it, but when you plug these tubes in, they can only go in the socket one way. And there's various techniques used to make sure they only go in one way. And on these tubes, the center post here has a key in it. You kind of see it, the key is kind of sticking out that way a little bit. A little hard to see, but it's there. And it's the only way you can get this to go in the socket. One way. Make sure the tube is connected to the circuitry properly. Now you know what I just did? What did I do? I stuck this tube, I just had my hand, stuck it back in the radio in the wrong spot. Okay, any leaks? Or any, Is that visible? That may not be visible. We got something here. Got something happening here. Yeah, and there's a whap in the tube. Is that visible on camera? Let's just let me darken this room down, and we'll see. It's visible. Yeah, you can see it now. Whoop! What? How come that light came on? Like this? Didn't I turn it off? I have an automatic light here, and I have the feeling it automatically turned on. You can see it now. Wait a minute. Oh, come on. Well, you can even see it with the light on. You don't have to worry about it. Short in the tube. Now it's shorting on setting number 3. We could get the book out and find out 3 means cathode to heater or something of that sort, but it really doesn't matter because any short is bad news in a radio like this. Seems pretty stable. Hey! Hey! What's going on there? There's a short in my tube tester. You know what's happening? I'm getting it between 3 and 4. This is a really cheap switch under here. Yeah, you know what? It's not a short, it's operator error. So just a warning about using tube testers. Tube testers will tell you a tube is bad when it's not. Son of a gun. I don't know what happened. Okay, I don't think it's indicating there's a problem with the tube. But a tube tester can tell you the tube is bad when it's not. It can tell you it's weak when it's still good enough. How can it tell you it's bad when it's not? Tube tester problems, or you made an error in this, or who knows what's going on. But don't throw a tube away on one test. That's what I'm getting at. It's tough for me to throw a tube away. I'm doing this test again for some reason. I don't know why. Okay, we're good to go though. If there was a real short in this tube, I wouldn't want to push this button. Okay, a few other thoughts went through my head there, but I'm going to ignore them. And for this tube, 6SA7, man, I have talked a lot today. 470 at the bottom, down here again, 3000 scale, just above, but it's above. And a really good version of this would be 750 again, be up about there. Well, it's working. Now the next test, 7346 with a 5. 734. Whoa. 5346 with a 7. Okay, so I changed the 7 to a 5, changed the 5 to a 7. 21, everything else is the same. Here we go. Well, that's a really good response. This is the oscillator section. So you remember I said the radio has its own little transmitter inside it. It's not transmitting out into space. It's just for use inside the radio. This tube is responsible for not only mixing those signals together, but helping to create that alternate signal, the local oscillator, often just short formed to LO. The LO. When we operated the radio earlier on, and I found it to be working, maybe not working great, but working, that proves all kinds of these functions are happening in the radio. The local oscillator is oscillating, the front end tube is amplifying, the output tubes are driving the speaker, these coils that are hidden inside these cans are in good shape. Generally, the radio's tuned up properly. I mean, all kinds of things are proven out by making the radio operate. And there's one more tube I forgot about, the Magic Eye tube. Okay, Magic Eye tube. Let's get it out of here. Let's just take a look at how they have it in here before we take it out. So, this is the eye socket. The eye tube, like any other tube, is going up here. This is glass, even though, man, you'd never know it for all the dirt that's on it. Then there's a rubber fitting here which is trying to prevent light from reaching through here. We don't want light coming through. This is the front panel, right? And if you have light coming through it from somewhere, I don't know where, it would show up when you looked in the front. You don't want that. So this is cowling. It's still pretty rubbery. The tube is adjusted with this thing here, just stuck. Let's unstick it. Okay. Adjusted in the sense that it's pushed up as far forward as you can get it. Okay, we're going to slip it off. We're going to leave the clip on. I'm going to try not to bend these wires very much here. These are often very, very stiff. One of the problems with these guys is there's almost always a resistor inside the socket here. So that means you have to sometimes take this whole thing apart. Again, I don't want to bend this too far, so I'm just going to grab my camera and swing it over here. There's the business end of it, the Magic Eye, which is a little TV screen. It's the same thing as an old style CRT TV screen. Same thing, being kind of a little bit of a generous way of putting it. Now we're going to see if we can get this off. Out would be a better word. See if we can get the tube out. There it comes. This is an older style tube. It has no center pin. This one, to make sure it goes into the socket the right way, 2 of the pins are fat. These 2 are fat. These ones are thinner. And it'll only go in the socket where these fat pins can fit. Magic Eye testing is interesting. So here's the Magic Eye, which I glanced at when we were operating the radio before, and I did not see a thing. No heater, no nothing. So this should glow green. I can show you one. So I have a number of instruments that have this kind of thing in them. So here's one here. It's the very, very same. Just flip this on. We'll let it warm up. This is what we should see. Yeah, and this one isn't the brightest one in the world either. There it comes. Now the camera doesn't do it justice. Down here at the bottom, there is no green. There is a pie-shaped opening here at the bottom where the tube is not lit. Very, very, very hard to see on camera. I can't really. You can kind of see it there. That's what it should look like in the radio, and it should look something like that in the tube tester too. The tube tester can test these tubes. Okay, Mr. Tube Tester. Now, there's a number of these tubes. There's a couple that are actually the same tube. 6U5, 6G5. It has two numbers. It's a Rogers tube. There's a good chance this is a replacement. These tubes only last so long. The radio lasts a lot longer. So these were money makers back in the day. But an awful lot of people, when the eye wore out, they would say, you know what, I don't really care. It doesn't affect the operation of the radio at all. It just makes the tuning a wee bit easier, maybe. It's actually a bit of a sales thing. I think really it's an attractive sales thing. They buy a radio with a Magic Eye. Why wouldn't you? So in the end, what happens is people let them die, and then they just leave them in the radio dead. And then eventually the whole radio is set aside, right? Years and years and years, decades ago. And eventually it works its way onto my bench. By the time it gets here, the Magic Eyes are generally dead. Okay, so we're going to look up 6U5. 6U5. So we'll look up here. I have talked a ton today. 6U5. 6U5. So we dial up this setting, 6.3 JR 5403. 5403. And 0 on the end. No other settings. So you should plug this in, the eye should glow, and the eye should be open, like I was trying to show on the other thing. I'm not going to pull this rubber off because I don't know what to expect. he says. Then he starts pulling it off. So this rubber's all cracked. Look, it's coming apart everywhere. That's why I wasn't going to pull it off. But for some dumb reason, I decided to pull it off. It's stuck here. So the disc there that you can see, that shiny disc, is to block your view down into the tube where the heater is. Otherwise, you'd see a red thing here along with the green on the outside. That's what that guy is doing. It might be affecting the distribution of the electron stream too. I'm not sure. Did I set this up? Yes, I did. 54030. Now this is going into a different socket. It's going into a 6-pin socket with the fat pins here. I think it's this one. In we go. Now I'm going to try to turn my light off again. Let's see what happens. Because apparently, 2 seconds later, it's going to come back on. There it is. Yeah, it's my automatic light, which I don't know exactly how to operate it yet. Okay, we'll leave the light on. You should be able to see this in the light. Anyway, there's nothing there. We do have to darken things down here. There's nothing there. So I'm looking now on an angle where I can see past the disc and look down into the tube to see the heater. And just as the observation I made when it was in the radio, there ain't no heater happening here. It's not heating. Okay, so we're going to watch the red light. I'm going to pull this out, see if the red light flickers. No flicker. So I think this guy has he's bit the dust. He's finished. He's gone away to that tube place in the sky. Too bad. I do have replacements. These are rare. These are rare tubes. So for now, as I say, it has no impact on the operation of the radio. So we're just going to leave it out, leave it aside, carry on with everything else. So the grand result is 2 tubes need to be replaced. The 2 6 SQ7s. Now I have some of those. I think I have them fairly handy here. 6 SQ7. Let me just get them out. This is most of my 6 SQ7s in this bucket. There's a lot in there. Some of these are tags on them with numbers. These are tubes I previously tested, and I have a chart. I can look up tube number 22, test result was so and so. This is a different tube, 12SW7. Well, what we're going to do is we're going to pick 2 unnumbered tubes. Did I say 12 at one point? This is a 12. It should be in my 12 bag, not in the 6 bag. 6 SQ7s. 2 of them. They are nice looking. One's a Marconi, the other's a General Electric. Not that I think that's much different. Let's just double check these guys. Get these done, and then get them into the radio. I could just put them in the radio. I mean, the radio is kind of a tube tester in a sense, isn't it? 6 SQ7. Okay, 6 SQ7. 6S Z Q Q R 6 SQ7. We're going to do the triode section. That's probably all we really need to do. JX. 0503 with a 6. No. This one. 1603 with a 2. 1603 2. 11 and 34. 11, 30 and 34. Press B4. Okay, so hopefully get 2. So if I get this done quick enough, pop these in the radio, we'll turn the radio on and see how different it seems. That would be the plan. So, you know, using all this vintage equipment, it's a fake short. Using the vintage equipment like I do, that presents its own problems, such as that thing we were just looking at. So that's the price you pay with so I don't think you can buy anything other than vintage tube testers. I can't imagine somebody's got a new one on the market somewhere. Okay, P4. Yeah, 470. 470. P4. Which is a good one. Okay. So that's going in. I'm sticking that right in. Now, I'm not testing the diodes. Pretty sure the triode functions, the diodes will too. In you go. 6SQ7. Okay, shorts. Just that funny thing again. So it's when this control is in between 3 and 4. But no, it's on 3. Okay. 4. It's right up there. Way above 470. Excellent. 2 excellent tubes here. 2 excellent tubes. They've gone in. Radio. Okay. All tubes are back in. You know, there are people doing this kind of work who the first thing they do is they jump on eBay and order a set of tubes for the radio because they don't have a tube tester to test them. And they figure the guy they're buying the tubes from has tested them, so that would eliminate trouble with tubes. That's too bad because most of the radios I work on, they have 1 or 2 bad tubes in it, and not much more than that. And a lot of them have no bad tubes. So I think a lot of people, well, let's just say if you're doing that, hang on to your old tubes. Don't throw them out. Okay, the volume is down because we expect the volume to be up this time. Radio's plugged in. The antenna is not connected. Antenna not connected. That's not the antenna. So we're going to put an antenna on it. We're not going to use the signal. And the reason for that is it's just too late in the morning for me to bother with more. Oh, it's up here. I'm looking for a cord and it turns out to be up here. The antenna will do the trick though. Okay. Antenna's connected. Speaker's still plugged in. We're on broadcast band, watching the dim lights. Well, what happened? They didn't go at all. Oh, because not turned on. Not turned on. Here we go. Still no dim lights. What the? What? Okay, hold on. Whoa. You know what I didn't check? I've been spinning this around. Maybe the power cord has... Oh, Jimmy made a terrible mistake. Well, that's exactly why I use those dim lights. Now, what's happened is my temporary power cord has come unclipped. Yikes. That's not good. Let's tip this guy up here. Tip him up. I think we're going to operate it sideways. just floating around in there waiting to shock me. Now because I have an isolation transformer on the power supply to the radio, it's a little more difficult for me to get a shock, but that could have been exciting in various ways. Luckily it wasn't. I should have checked it. No, on the wrist. There. Okay. Now, there's nobody here to punish me or chastise me, so I have to take care of that part of the deal too. Now we're ready. Volume down, switch on, and we'll leave it on its side. Better view of the smoke that's going to come out of it. Here we go. You can't see the lights. See the lights. Watch the lights. There they go. And they are behaving exactly as they should. They're dim and getting dimmer. Okay. Man, the volume control here. Come on, radio. I got the volume full up. So we're on low voltage. We're running this set with 80 volts. That's stupidly low. Okay, we're going to put it on full. I'm going to turn it down. Ooh, something's giving up the ghost in there. That lightning sound? Okay, I'm watching this light on the panel to see if it dims a bit. See, a crackly problem like that could be something that's never going to damage the radio, or it could be on the verge of blowing it right up. Which one is it? We don't know. For now. Okay, so volume check. That's what we're doing here. Get back to it. So look at this. A little bit up. Tons of volume. And as for tuning it, well, that's working. Station right there. I can hear it. Now, that horrible pulsing noise, it's just all these weird sounds, nothing wrong with the radio. Those are really here. Dirt in the volume control. Something else we haven't figured out is these push buttons. When do they get engaged? None of them are pushing the tuner. I'm not pushing hard enough on them. Yeah, there it goes. Did you see the wheel spin? Watch the wheel. But these need to be switched on. And where exactly does that happen? Well, that's a good question I don't know the answer to, but that's okay. We'll sort it out as we go. It's the sound of the tube tester being shut off. We're off. We're done. We're done for today. Great. Okay, so if I carried on with the repair of the radio with these weak tubes in it, at some point I might have started looking for a cause for the weakness other than the tubes and drove myself wacko. That's why we tested the tubes today. So thanks a lot for watching, and we'll see what I do tomorrow. It's another beautiful day here. We're just so lucky. The weather has been absolutely fantastic. So see you on the next video.